So in this tutorial, I'm going to talk about downloading some of the images and segmentations, just image segmentations. Layla showed you how to actually download the meshes that are generated off of the segmentations. But in the case where you might be interested in actually analyzing some of the raw imagery with the segmentations, for example, for creating your own detector of a specific organelle, or even for just doing some sort of image processing and analysis on the images themselves, you might be interested in actually downloading these from source. So some of the tools, the libraries that you want downloaded are Cloud Volume and the Imagery Client, both of which are installable with pip. Okay, so to start out, we just have some basic imports, pandas, matplotlib, and numpy. And the very first thing we're going to do is to set up, I should run that cell, is to set up the image sources. So just as I had pointed out in the NeuroGlancer tutorial, you have an image source, the EM imagery source, and the segmentation source, which are two different sources and that have been used and that Casey and Layla also went over. And so we're going to say, okay, these are the places we want to download our images from. And I'm going to show you actually two methods of doing it. One is by directly using Cloud Volume, which has a lot of the power of directly actually going and grabbing that data, and also a second method, which is a kind of wrapper that's written for actually downloading that to more specifically for our data. Okay, so the very first method I'm going to do is directly with Cloud Volume, and here we first start out with the import statement, and we say, okay, let's first initialize our Cloud Volume connection and say we want to download some of the EM imagery. So the very first thing we do is to set up that Cloud Volume connection with this command, and we say, okay, now that we have this image source connected, what are the bounds of the data? And if you look at that, it will tell you what the XYZ bounds are. So this is the lower left corner, and that's the upper right corner. So and these are all in voxels. So it tells you really how much you have in there. So the first example we're going to do is say, okay, let's just pick some arbitrary 500 by 500 box in the middle of the volume, and say, let's say one section. So I'm going to just pick some bounds somewhere in between, right in the middle of the volume here, and say, okay, I'm going to define these bounds this way and download the image, which I can do right away with this command. So if I look at the shape of the image that I've downloaded, it's 500 by 500, and it's just one slice here because I'm just going one in Z. And now I can actually look at what I've downloaded simply with matplotlib, and voila, there's the EM imagery right there. Okay, so now I can do something very similar with the segmentation. Again, I initialize the Cloud Volume connection right there with the segmentation source this time. And if I look at the bounds, notice that these bounds are different from the ones we had before. In particular, if you scroll up your notebook, you'll notice that this is actually exactly 1/2 the size of the image volume. And the reason for this is that the segmentation was actually computed on 1/2 of the resolution. So the original images are 4 by 4 nanometers, and this is 8 by 8. So, so that's why you have less pixels or voxels in this particular bounds. However, you can easily relate them by reshaping them in either direction. Okay, but so let's go ahead and now download a piece of that segmentation. Let's just divide the bounds exactly by 1/2 of what we had downloaded before. And we'll say, okay, let's go ahead, and that's going to download. And let's say, okay, let's look at it. So we'll run the same command again that we ran for the EM imagery. But unfortunately, what we see is something like this. And the reason is that the IDs, if you remember, so the segmentation really contains the IDs of the objects that are present in that particular box itself. And some of those are just very large values, and there's no way to easily control that range. So in order to actually look at them nicely, you can easily remap these. And we use the fast remap toolbox for, you can use the fast remap toolbox. It's you can definitely use just numpy unique and write your own command, but fast remap provides that and does that pretty efficiently. So I'm going to show you how to use fast remap here. So the first command here is just unique, which will actually calculate all the unique IDs within that box and give you the counts. So if we look at those unique IDs, it's now telling me, okay, all the unique IDs inside that box are listed here. And now I can actually remap those and renumber those to something else so that they're not these really weird values all over the place. But let's say I just want to label it from 1 onwards. So I'll say, okay, let's go ahead. And so now I've remapped all my IDs between 0 and 18. So I have only 18 values. And that's stored in this remapped seg variable here. So I can now visualize this pretty easily by just, again, using matplotlib, and that looks something like more like what I expect. So as I mentioned before, the size of the segmentation and the imagery are different. So if we actually look at this, we'll see that the segmentation shape is 250 by 250, whereas the image shape was 500 by 500 for exactly the same thing. So if you want to overlay these things, you definitely have to do some sort of reshaping in one of the directions. So instead, we've developed a cool toolbox called Imagery Client, which automatically does a lot of those things for you. And might be easier for a lot of the purposes. So I'm just going to show you how to do something similar now using this toolbox. So the first thing we're going to do is import Imagery Client. And this again should have gotten installed with the environment if you use the environment YAML file. We initialize the Imagery Client with the same image and segmentation source that we used before. And now let's do something slightly different, not just pick some random box. Let's say we want to do something interesting where we want to go pick a synapse and look at the imagery around it. So I'm going to read from this CSV file, the SOMA subgraph synapses, which Layla just showed you about, where she actually mapped some of those onto a cell. And I'm going to randomly pick some synapse, let's say the 400th one, and grab the postsynaptic cell ID and the presynaptic cell ID for that specific synapse. Okay, and so I run that cell. And now suppose I just want to look at, 5 consecutive sections, like around that synapse, a couple, 2 before and 3 after. I can go ahead and set bounds using the center position of that synapse. And I say, okay, I'm going to go in XY 150, 150, so that I have a 300 by 300 box, and then go 2 Z's before up to 3 Z's later. And so I'm setting my bounds this way. And once you have the bound set up and the imagery client object initialized, all you need to do is just run this one line of code to go ahead and actually download those cutouts. And what this will do is is to give you 2 things back. One is actually all the imagery, and the second is the segmentation masks. So the imagery is simply just a NumPy array, a 3D array that contains all the imagery information. And this one is, the second object is actually a dictionary. which contains each of the IDs of each of the root IDs or the objects that are present. It has an entry for each of those in the dictionary, and contains masks basically. So it's 1-0 values of those, so that you can actually identify. So for example, if you want to look at the presynaptic cell and the postsynaptic cell that we've identified here, you can specifically look at those rather than all of the objects inside the segmentation. So let's go ahead and run that. And once we have that downloaded now, we can try to plot these. And so what we're doing here is really showing the images, as well, the EM images, as well as the postsynaptic and presynaptic masks in those images. So you can see these are, if you scroll through these, you'll see these are consecutive images. And again, if you look at the two columns here for the postsynaptic ID as well as the presynaptic ID, you see how that how the mask changes over consecutive sections. So you can now save these images and perform any kind of analysis that you would like to. The last thing I'd like to point out before we wrap up this section is that the imagery client has actually resized all of these images to the same size, so you can actually overlay these directly and use those masks directly on these images, which can make your life really easy.